Let's look at the following problem associated with conservation of energy. Tarzan, whose weight is 700 newtons, swings from a cliff at the end of a vine, 20 meters in length, as shown in figure below. So that is him, and that is the vine. He descends 3 meters as he moves from the top of the cliff to the bottom of the swing. So that distance right there is 3 meters. Given that the vine will break if the force on it exceeds 980 newtons, find the greatest force on it during the swing, and will the vine break? First, let's sketch the free body diagram of Tarzan. So you have the vine, and I'm going to represent him as a point mass. So the forces are his weight, which is 700 newtons, the tension in the vine, let's denote it by T. Now this T is the force on the vine. So if T, the tension, exceeds 980 newtons, the vine breaks. Note that as he swings, he goes through part of a circular motion. That means there is a velocity or speed which we can denote by v. Because this is part of a circular motion, you should also label centripetal force along the center of the circle. The center of the circle is here, so that centripetal force acts along the vine. Let's assume that this angle here is theta. So theta is the angle that the vine makes with respect to the vertical. So that means this angle is also theta. So the component of that weight along that vine would be 700 cosine theta. So what provides the centripetal force is the difference between the tension and the component of that Tarzan's weight along the vine. So that means it is T minus 700 cosine theta equals the centripetal force, which is the mass of Tarzan, times v squared over r. R in this case is the length of that vine, which is given to be 20 meters. You see, rearranging that equation, you get tension, or the force on vine, equals 700 cosine theta plus mv squared over r. In order to find the greatest value of that tension, we know that theta has got to be 0. And v, we can show, will be maximum when theta is 0. So when theta is 0, the vine is vertically downward like that. If this is the initial position of Tarzan, and that's the final position of Tarzan, then from conservation of energy, we say that the sum of kinetic energy and potential energy at the initial location, since Tarzan was at rest at the initial position, so the kinetic energy at that position is 0, the potential energy there is mg h. Now what is h? H is 3 meters, because we can take the potential energy at the final level to be 0. So all the subsequent potential energies are measured from there. So h equals the kinetic energy at the final location, which is half times m times a v squared. Let's assume it's moving at that final position with speed v, and the potential energy there is 0. So m goes away, and we see v squared is 2 times gh. So v is maximum when h is maximum, and h is maximum at the lowest point, namely the point where theta, or the angle the vine makes with respect to vertical, is 0 degrees. So let's substitute all this information inside this equation. When theta is 0 degrees, cosine theta is 1, And from this equation, v squared is 2 times gravity times h. So let's substitute that in here, and we get mass of Tarzan over the length of that vine times v squared, which is 2 times g times h. Now we are almost there. So the tension equals, the greatest tension that is, equals 700 plus the mass of Tarzan is weight divided by gravity. G value is 9.81 meter per second squared. Don't forget this R. This R is 20 meters, so divide by 20, times 2 times G times H, and H is 3 meters. So the G goes away, and you get the maximum tension to be 910 newtons. So the greatest force on the vine during the swing is indeed 910 newtons. And since it is less than 980 newtons, which is the force needed to break the vine, the answer to the question, will the vine break? The answer is no. And that solves the problem. Thank you for watching.